button here. All right. I think we're ready to get started, gentlemen. Are you ready?
I'm ready. Jimmy, you ready?
Yes, sir.
Kick us off, Paul.
All right. Welcome, everyone, to our very first PTZOptics, Comtronics, and Detect It Industrial Manufacturing webinar, a webinar that we hope to host quarterly. There's a lot going on in this industry, and I'll let Rick kind of kick us off with a little introduction.
So welcome, everybody. We're here to talk about integrating AI vision into manufacturing and what it takes, what people think it takes, how people think it's complex and it really isn't, how easy it can be to deploy an AI vision system with Comtronics and Detect It and PTZOptics. So we're going to take you through that.
Good afternoon, everybody. I'm Jimmy Haugen. I'm Vice President of Comtronics, handling all sales and marketing globally. Good to be here today.
And I'm Rick DiLoretto, Chief Operations and Marketing Officer at Detect It AI Software.
Hi, everybody. Paul Richards here. I am the Chief Revenue Officer at PTZOptics.
I love that title. All right, so everyone in manufacturing knows their biggest problem right now is manufacturing quality and what it costs in terms of time and money and manpower, returns, warranty, recalls. All that is related to quality. Suppliers are spending lots of money implementing quality control measures, but bad parts are still getting out. A lot of reasons for this: a lack of capital to fully automate. Robots are expensive. Manual processes, humans make mistakes, substandard quality inspection systems, Industry 3.0 versus 4.0, constant churn of personnel, lack of training, and then you have employees that are maliciously looking to hurt an employer. Humans, we're wonderful, but sometimes we suck. Humans make mistakes. 23% of all unplanned downtime as a result of human error. So like 7 out of 10, we're about that good. That's not great. 45% of manufacturers realize there's room for improvement, and over a span of 3 years, 82% of companies had at least one incident of unplanned downtime. There are existing processes, but they're super expensive and inadequate. We're finding lots of our customers are bringing things to us that they just can't poke a yoke. They just can't figure out how to quality check. Typical quality line would look like automate what you can with robots, but that's super expensive. Then you've got a bunch of manual assembly stations with humans with their 50% error rates, one after another after another. Typically, you'll end with a poke-yoke system and a bunch of cameras. Everyone back up, take a picture, send it to the cloud, see if the cloud thinks it's a good part or not. And then you've got a manual final inspector at the end anyway. So a lot of opportunities to miss things in this type of environment. So what can you do? What's the solution? Well, one of the solutions is to deploy AI to catch bad parts. Detected is an AI tool that we've created specifically for manufacturers to deploy to catch bad parts. We call it human level vision without the mistakes. It's a live video. I'm sorry, Paul. It's a live video-based system, not pictures, using advanced AI neural network technology for fast, accurate detections. It's designed for low-cost implementation using security and broadcast level cameras and off-the-shelf PCs. We are not locked to one hardware or camera manufacturer, although we love Comtronics and PTZOptics. We're fast to implement and easy to use. On-premise, we are not cloud-based. Everything's behind your firewall, on your factory floor, lockdown. These are the general AI myths we come across when we talk to some of our customers. That it's expensive, it's complex, it's unreliable. A lot of people citing budget constraints. We don't have the money to implement it right now. It's too complex to customize. A lot of the solutions are code-based. You need multiple coding tools to learn and to do and to make changes on the nets is costly. The reliability and security is an issue because a lot of the big boys are cloud-based. We don't want our parts in our our IP going up into the cloud to get stolen. So that's what we were hearing. The reality, though, is it's actually really, really easy to implement AI with Detected, Comtronics, and PTZ optics.
Yeah, and I can jump in here too.
Yeah,
Yeah, when we talk about just as a manufacturer of industrial computers, I know Rick, you can probably attest to this. Is when we're going into our end customers, they're always asking about AI. It's the talk of the town. But as Rick alluded earlier, is they have preconceived notions on it's too expensive, it's a lot of manpower. The other thing we're finding is when we standardize in a hardware platform that we know detected software can run on, we know that PTZOptics, their cameras can run on. What we've done is we've really standardized and we've kind of certified this product so that we know it works. And I'm sure, Rick, you in past deployments, you kind of put the onus on the end customer. Here are the specs to run our software in the cameras. Well, what
yep.
we find is if there's not a standardized hardware platform that we know works, you guys are getting calls saying, hey, your software's not working. We think it's the hardware. They have a lot of inconsistencies in hardware platform out there. So really, when we talk about making AI easy to deploy, it's really important to have that standardization. And that's really what we've done here with both Detected and PTZ is whether it's a smaller implementation or more of a larger enterprise implementation, we know exactly what we need from a hardware standpoint.
Love it. And our software is for ages 10 and up. We've really made it that easy. We have Girl Scout troops come into our office and earn their technology badge making neural nets with detected software. So if Girl Scouts can do it, I'm pretty sure everybody else can. Paul, you want to tell them about PTZ cameras?
Yeah, I mean, I have to say that it really is an awesome tool. I've got a quick little video that I'm gonna play as we discuss this. But essentially, I was so impressed when I realized that Detective is not designed just for specific use cases. You can take video of anything and train it to do those detections. And as you know, in industrial manufacturing, it is a wide variety of types of parts that we're checking, types of products that are being designed, and viewpoints, right? Like right now, we're looking at an overhead view of a production line.
With a
Some
worker in the field of view.
Yeah. I mean, it's sometimes you're seeing, by the way, the camera moving. And when you're seeing the camera moving, you've basically got one PTZ camera that has several presets in a flight path. And Detect It has designed their software to be able to automate the process of checking everything. At Automate this year, Rick, it was just incredible. I don't want to go like totally down a rabbit hole, but you were showing how you were doing step by step instructions for people on the plant floor, even going as far as locking a torque wrench so that it couldn't be used until each thing was checked. I mean, what you can do with this is so wide and flexible, but it can really go deep and be incredibly advanced.
100% agree.
So I've been blown away. I've made a couple of these neural nets myself, and I have used some of the cloud options that are out there. You know, we are a robotics company. We work with a lot of cloud solutions and we work with a lot of AI. And what Detected has built is something that I shouldn't be playing with AI, and I can do it. So it is awesome from an empowerment perspective that I've worked with 60-plus-year-old men who are in the factory floor in the QA department who are just
Look at
saying,
this one.
please.
We're flying one of your PTZ cameras around the B side of a headliner, checking for all these dual locks, which are black on black, which is not easy to do.
Mm-hmm.
And
And here
so,
we're checking electrical connectors on the B side of a fascia to make sure they're closed.
and
Like
Rick,
that's a
why don't you
millimeter
explain that?
difference between open and closed.
Yeah, like, could you talk about that for a minute? Because you need to have a certain level of clarity to get these millimeter level detections, right? So that's why the robotics and the optical is so important.
Yeah, so a rule of thumb is if you can see it on a monitor and you can teach someone else to see it on a monitor, you can teach detect it to see it on a monitor. So in the situation of the electrical connectors, with your camera, we're able to fly that over to a connector, zoom in to a zoom point where we can clearly see that that clip is open or closed. We take a little video of that in the open position. We take a little video of that in the closed position. We label the one open, we label the one closed, we train the net. It's just that easy. The camera comes to that position, it knows the two positions, tells you what it sees. It's that simple.
Yeah, and I've designed some of these myself. Um, Detect It has, and one of the things I talk to a lot of our industrial manufacturing customers, I just say, listen, take your smartphone out, take a video of your piece, and send it to Detect It. They have a challenge system where they will return to you whether or not what you're looking at can be detected. And you'll see a slide later on today where I'm working with Strong Arm Manufacturing, a really great Pennsylvania, USA-based manufacturer, and they manufacture some really advanced pieces of hardware. I mean, we're talking like hundreds of thousands of dollars for pharmaceutical companies, and they have QC problems. Why? Because there's 400 parts on there. Of course, there's going to be QC problems. And they were blown away that they could just take a video of it, send it to Detect It, and just know that the proof of concept could work, because that made them feel comfortable to like, okay, if it can work, let's take something that takes 8 hours for a QC person and turn it into more of like a 15, 20-minute process of looking at what the AI is telling us, Detect It, and then very quickly kind of honing in on there's 400 parts here. Which
Yeah.
one of them is the one we need to focus on?
Yeah, and that challenge is free. We'll do it for free, and it's usually within 24 hours. So you can quickly see if what you're dealing with might be a possible solution using Detected.
Yeah,
So,
and I think too, I can chime in here as well from as a manufacturer of industrial computers, is this is something we use as well to make sure like, hey, is the GPU seated properly? Is your RAM seated properly? Is your storage? So it again, it takes away that that human error that can possibly happen so that we know everything is 100% inspected, which is not a lot of the times the case when you're talking about industrial PCs. So they'll take a portion of, let's say it's 1,000 units, they maybe will test 10% of them. This gives you the ability to test things 100%, and out the door it goes. So
Paul, can you
really, really
pause it
cool.
on this one for a minute?
yeah.
So I want to talk about this one because this is a really cool application. This is spatial tool. This is where is the tool? How do I control torque? Well, now they're using arms or they're using, different mechanics to try to figure out where the tool is in the field of view. But for us, we put a camera, a borescope camera on the head of the tool on the left. We put an overhead camera on the bridge rail above. And since that bolt pattern that we're seeing on the left is repeated 4 times on that seat frame, we know what bolt in that specific area you're on, but we don't know what area you're on in the seat itself. So when we take the two cameras and put them together, we know exactly what bolt you're on and what part of the seat you're on. So we can literally control the torque of that wrench bolt by bolt. And if you need to enforce a tightening sequence, if you go to section 3 and skip section 2, we can have the PLC disable the wrench. There's just so many things you can do. If you have a cross tightening sequence, we can enforce that. If they go to the wrong bolt, we can lock it out. Just some amazing things you can do that haven't been possible before.
And Rick, I wanted to just ask a kind of simplistic question, based on what we're looking at here. There's boxes, right? There's boxes being shown on detections, and then they go out to the edge where you're seeing what the detection is and the confidence rate, right? So that's that
Right.
number there.
Yeah, that's how confident it is in what it's seeing.
And one of the things I've noticed with the customers we've been working with is that sometimes it's color coded, right? So sometimes you might have green for good and red for bad. And I also noticed that sometimes these little detections on whether it's the top right or the top left, sometimes they're bigger, sometimes they're smaller, sometimes there's additional information. So it seems like it's really customizable because if you've got a lot of detections, you need to make space for a lot of notifications. But how does that process work? Because I see every time it seems like every customer has a bit of a different implementation of the way that they're showing the detections.
Sure, that's all customizable in Netrunner. Our software has two components: Net Builder, where you create your neural net. It's like your sandbox, and then Netrunner, where you deploy the neural net to the edge. So in Netrunner, you can configure what you want to see on screen, how thick you want the box to be, where you want the label. Do you want the label in the box, the top of the box, the bottom of the box, detached from the box, on the right, on the left? um, the color of the label, you set all of that when you're creating the net, and you can change the color of that. We like red and green for good and bad because it's just visual. It instantly visually tells you good or bad.
Cool. Well, this is such a cool video to show. I am going to move on to our next slide, but just wanted to give you guys a really good look at what these detections are and the wide breadth of different
Yeah, and for those
applications.
who haven't seen AI working in manufacturing, that's literally what it looks like. So this is the interface for our builder software. We break down creating a neural net into 6 modules. Um, Step one with Net Data Collector is take a video. You don't take pictures. You take a video camera. You take a video of your part. You move it all around the part from different angles to create a rich data set. You can adjust the lighting during this phase. So the lighting is bright, the lighting is poor, all the possible lighting conditions you're going to get looking at that part. Step two is to draw a box around that thing in Net Builder and give it a name. Step three is to train your net. That is all happening in the background. You tell it what you want. Net Builder creates the net, does all the specifications in the background, how many iterations, the frame rate, all that stuff that you don't need to worry about in code. Step four is to deploy the net out of Builder to Runner, and you can deploy to any runner in your line as an IP address. You're basically taking the net and sending it to an IP address somewhere. Step five is to run the net. We have a net archiver there. That's just to manage nets. You don't need to do that every time, but that's a shortcut to Net Runner, which is our edge software that runs the net on the plant floor. So typically we see 2 levels of deployment at our customers. This is what we call a local approach, and a lot of our customers start this way. That's where you create your net in IT or in engineering or wherever, and then you deploy that net to a second computer, and then you run that computer on the plant floor. A little computer like this will support 8 to 10 cameras based on the hardware specs and the GPU. And then
Mhm.
if you need additional lines running, you deploy additional small computers and cameras. So every time you need to deploy a new solution to a line, you get a new net runner on a new small PC with some cameras and a monitor, and that's how you run it. Jimmy, did you want to talk about Comtronics options at this point?
Yeah, I think the big focal point here is what I kind of touched on before. So the way that because we do everything in-house, we have the ability to really customize what PCs are needed. And that again is if it's a local approach, we have the ability to provide each PC for how this deployment is going to go. We know again that it's tested, it's tried and true, and we support everything. So
Beautiful. And those can be PTZ cameras or fixed cameras, any type of cameras, Paul.
Beautiful. Yeah, one of the great things about this that we love here at PTZ Optics, it's so forward thinking. These cameras just need one Ethernet cable. So that Ethernet cable can power the camera, it can control the camera, it can send the video back to detect it, and then you just have one piece of software, detect it, that can control these cameras and schedule the flight path. So
And you know what we're doing, Paul, too? What we've done is we can use your PTZ cameras 2 ways. We can send them to a specific spot to look for something, or we can have them hunt and find. Well, they'll just scan the part, and when they find the thing they permitted to find, they home in on it and zoom in and give it an inspection.
I didn't know you were doing that.
Yeah,
Is that new in the
it's
new
awesome.
yeah,
program?
that's new. That's new.
Oh, we got to show that next quarter when we do the next webinar. I haven't seen that yet.
Yeah. All right, so a lot of our customers will do their first deployment locally, and then they'll switch to a network approach. So the network approach, you move your net runner into the IT closet and either use or put in a robust video LAN. And all your cameras are just connected to the video LAN with an Ethernet cable, and everything's running just via Ethernet to the IT closet. So this is a lot cleaner.
Hmm.
You obviously need a much bigger PC, Jimmy, to run this
Correct.
type of power. But we've got people that are using, blade servers to run 1 and 200 cameras on the plant, all from the closet.
And Rick, let's talk a little bit about these multi-camera deployments. So, is this happening because one neural net needs to be able to be processing multiple angles, or can you just explain why one video camera is not enough and how you get to this point?
So there's a lot of reasons you need more than one camera. Sometimes you need to look at the top and the bottom of a piece at the same time. Sometimes you're running the same part on multiple lines. So you just deploy the same net across multiple lines. You literally copy and paste that same net onto multiple lines. Um, Sometimes you just want more speed. Your tack time needs to be quicker. So instead of one camera looking at an entire piece like a headliner, you'll split that into 4 cameras, each looking at a quarter of the piece, and then your tack time goes down by 75%.
Interesting.
Yeah, I think too, if I can just chime in from a hardware standpoint, is when Rick alludes to kind of more of a cleaner deployment, is you're managing all of your IT, your compute power within just kind of one location. So you don't have separate individual computers out on the plant floor. So it's a lot easier to manage. And we've also built in a software application where it is proactively monitoring everything that's going on. So if there is any issues that pop up, we're able to send either a text or an email to someone that's on the IT staff there, just to let them know that there might be something going on. So this is a really powerful and easy way to deploy.
We're
Plus,
getting
I
a
don't think,
question here, Rick.
yeah,
Go ahead and finish that. And they have a question from the chat.
sure. But I don't think we've talked about this. We also interface directly with customer PLC and MES systems. So we will
Yes.
tell the PLC what we're seeing. The PLC will make the decision what to do at that point when they get that notification.
Interesting. I think we're going to get some questions about this layout, and we've got one here from Kunal saying, if we rule out the PLC here in the picture and control everything from the desktop, are there any areas we should be aware of or other fixes to make this work?
I guess I'm not sure what he means control it from the desktop. Um, if you don't have a decision-making component in your system, that's going to be up to humans then to do something when Detected finds a problem. So when Detected gets a bad part, it's going to show you on the screen. At that point, you need to configure what happens. What happens when Detected finds a bad part? Does it send a text message to someone? Does it set off a bell or a stack light? Does it send a siren? Um, Most of our customers use PLCs to make a decision on that part, what they do at that point. Do they stop the line? Do they kick it out for rework? So if you have the option to control it from your desktop, it will work. It'd just be probably more human interaction.
Got it. Yeah, and a lot of the projects that I've been in haven't got there's actually there's like human detections, right? Like it's like there's actually a human just being augmented by the detections. So we're not in some cases, we're not completely eliminating the QA process, but just making their process easier and more effective. Um, but you're saying that in many cases, your customers are allowing the PLC to make those decisions about good and
Yeah,
bad.
you can do it either way. You can do it either way. You can augment your humans or you can eliminate them and have it all done automated.
Got it. Okay, so yeah. Oh, we got another question before we run on. So I want to make sure this is. Please ask your questions, everybody. If you've got questions, that's
Yes,
why we do
please.
this.
Absolutely.
Here's another one here. We plan to control a robot using the feed from the Netrunner so we can build a script for tasks. I just want to make sure that the PLC is not a must. I thought that's where he was going
Uh,
with this. Like he's going to use your custom scripting, I think, options that you have, Rick.
yeah, no, in that regard, you don't need a PLC to control the robot.
Yeah. And I noticed this, and I actually think you had it was kind of in the video. At one point in here, you had the Netrunner shown. There it is, right here. This is the Netrunner. You can kind of see it a little better. And there's this
Yeah, that's the interface.
you've got this scripting docs area. Is that what he's talking about, Rick?
Yes, you can custom script in Netrunner.
Why don't we just really quickly go through this? So the Netrunner is used to run the neural net. So it's kind of at the end of the chain, right? You've recorded your video, you've labeled the video, so you've got your detections, you have created the neural net, deployed it. Now you're ready to run it in Netrunner. Take us through these options here, Rick, of what's going on. Is this multiple cameras at once? What we're looking at?
Yeah, you have two dock windows open,
Okay.
showing two different cameras. You can have multiple windows open, showing multiple camera feeds in one Netrunner.
How many can you show in a Netrunner?
Till your hardware fails.
Wow. Okay. So that's
So
why there's this
there's
add
no
camera.
software limitation. You can make postage stamps if you want. And the really good news is once you get a layout that you like, you can save that layout as a preset.
Okay, so I think I see what's happening here. So the add camera dock, you can just keep doing that, and you're just adding more cameras,
Yep.
views.
Yeah, add camera dock, pick a new IP feed, add a camera dock, pick a new IP feed, and each one of those camera docks gives you options what you want to see.
Now, is it the same neural net though applied to all?
No,
No.
you can run multiple nets in multiple windows.
Wow. And then so that makes sense. You got this add camera dock. You want to have multiple views. You can have multiple neural nets because one view is looking at it one way, one view is looking at it another way. What is this statistics dock here?
So that's a way to look at stats from that builder, how many things it's seen, where it's seen those things, the coordinates. That feeds our data server.
Got it. And then the scripting doc, this is what Kunal was talking about here. These are scripts that you create to say, hey, if there's a bad part, or if there's a good part, if then this,
Hey,
that.
Paul, go to the beginning video, the one with the headliner, because that's got custom scripting.
This right
So
here?
yeah, everything you're seeing on the screen is scripting. So
okay.
it's showing you the serial number of the part it's reading, the build code, the 3-digit code, and then each position it's going to. All this is custom script on screen.
That makes sense. So when
Mhm.
you enable a custom script, you are expecting the output to be on top of the video?
Yeah, that's one way you can do it.
Hmm.
Like that script was created to show your results on screen.
Got it. Okay. This is great. People are really excited about this. Got another question here. Is Detected capable of physical real coordinates from the image? Say that you know the dimensions of the part on the screen right now, and you detect a point. Can you get the physical coordinate of that point from one of the edges of the part?
Yes.
Wow, you can do that?
Yep. Yeah, we have one of our customers is using us to locate north on the part, so that a robot arm can come and pick it up in the correct orientation.
Wow. I knew you did some
Awesome.
stuff like that because I remember seeing one of your detection videos where you were showing like if a bottle was full or if a bottle wasn't full, but I didn't realize you could detect an actual physical coordinate.
Yes.
Incredible stuff here. All right. Well, we'll keep moving on here. Very interesting. This is really cool stuff, Rick. Okay.
Really cool.
Thank you.
So I thought it'd be good just to give kind of a high level overview of who Comtronics is. So we're a US based manufacturer of all things industrial computing. We design, develop, and support everything in house. So we are not buying finished goods from overseas and white labeling them. Everything is done in house.
Where's your office?
Yeah, we're in Georgia, so our main manufacturing facility is in Georgia. I'm actually out of the Minneapolis area, so that's where our sales and marketing team sits. And then we do have an office in Taipei in Taiwan, where a lot of our design engineers sit. They do a lot of our motherboard designs, and our SMT line is over there as well. So um, we are a U.S. based company, and really our focus is all things industrial computing. That is fanless, smaller form factor PCs that Rick was kind of alluding to that we would use in more of a local environment, to all the way up to very high powered GPU based PCs that you're seeing here on the screen, that we use for AI machine learning applications. We do a lot in the HMI space, so we have HMI PCs, different sizes.
And I
Uh,
just found out you do monitors as well.
we do industrial monitors, yes. So that is big. So we do install a lot of monitors for KPI metrics, or when you look at Detect It, to actually view the video on. So again, all things industrial computers. When you look at kind of a differentiation and advantage, there's just a couple areas I wanted to point out. When you look at lifecycle management, especially on like the x86 platform, so Windows, um, all of our components are industrial. So Intel-based, 15-year life cycle. We really try to be consistent on our design. So we use a lot of the same motherboards, which allows us to, drive down the price of our solution and really pass along savings down to our customer. I think another thing that's important is we really try to focus on open standards and scalable architecture. And what I mean by that is, um, when you look at the types of the deployment that Detect It's doing, is there's a lot of different configurations on how that can be deployed. So we can really hone in on each individual PC that needs to be used in a specific deployment, but also is if you get a computer out there and you need to do like a refresh, so you need to upgrade the storage or upgrade the memory or add some more IO. Maybe you need a more powerful GPU. We're able to do that without you guys having to procure a whole another unit. We really focus on a collaborative effort. So we really try to consult with our end customers. We're not a transaction-based business. So again, in working with Detected and PTZ, is we want to understand the whole scope of what these deployments look like, so that we can put these solutions together to make it really easy to deploy, reliable, and a highly supported solution. All of our support is done in-house. I think one thing that's important is everything is 100% certified and tested. Um, and we offer manufacturing support services globally. So
Jimmy,
that's,
can
yeah.
you quickly take us all through your Blade server? Because when we were at Automate and you were next to us, my whole dev team was over there looking at that thing. Can you tell us why they were so fired up about it?
Yeah. So thanks for bringing that up. We actually were a finalist for the Innovation Award at Automate for this animal. So basically, what you're seeing here, the bottom,
Bottom
what we
right,
call,
right?
yeah, the bottom right. Yep, that's and we just launched this at Automate in May. So this is our NVIDIA Edge server. And what you're seeing there is there's 10 nodes. Those nodes are actually NVIDIA chipsets. So they're running NX or Nano, and they're system on chip. So it's the GPU plus the processor. So they're little tiny, tiny nodes. But what's really cool about this is we designed it where you can put 10 of these nodes inside this Blade server. So it's a 1U chassis. There's a 3-layer switch in there. So what we were talking about before is you can install one of these and then everything's run via PoE. So there's a 3-layer switch in here. So you can run many cameras on one of these servers just via PoE. So you don't have to pull power to where you're at. It's all PoE. And then on top of that, as I mentioned earlier, is we have a software application that's monitoring all of the activity that's going on. So it's taking thermals. It'll show you thermals. It'll tell you about utilization. If for some reason one of these nodes does fail, you can just shut down that one node, drop another one in, and you're off and lively. So it's a really cool piece of technology that allows you just to manage your installs in kind of a one fell swoop
And
area.
then could you use multiple blades at once?
Absolutely. Yep. Yep. And that's what a lot of our customers are moving to.
Awesome.
Wow. So cool. Comtronics even has some of the smaller units with PoE built in. So when I saw that, I was like, wow, if I needed to deploy 2 cameras in a production line with Netrunner, Comtronics literally has units that will power the cameras as well. So you don't need to put PoE switches. It's literally an all-in-one system. So they have some unique products that are industrial grade. And, he's not putting the prices here, but they are reasonable for what they are. With this, if you want this to last and be rugged for industrial use, honestly, it's not much more than the consumer powerful stuff that's out there. I don't know how you're doing it, Jimmy.
Yeah, then you mentioned PoE, but we can also run 5G as well on that same little unit, which is
Yeah,
pretty cool.
I am
So
just like so excited about testing some of this stuff because it really becomes more than a computer when you're delivering PoE, when you're delivering cellular, when you're delivering the compute all in one industrial grade box. I mean, this is cool stuff.
yeah, and that
Really,
bigger
really
box
is.
up top, if you just go back for a second, I just want to talk a little bit about, so you can see all the PCIe slots there that you can drop GPUs in or power over Ethernet or whatever it may be. The important thing here is internally, we have 3 areas that we do heat dissipation on. So internally, there's actually heat pipes that are cooling the physical processor. You can see on the far end, there's a heat sink that dissipates heat. And then on this far side, you can see there is some venting there, and that's really critical that's where the GPUs sit, and you have to have some venting just because of the power that the GPUs put out. So it's a really cool design, well built, incredibly reliable. We have thousands of these out, and we haven't really seen any failures. So it's a high powered machine with a lot of I/O and different configurations. So it's a really cool unit.
Excellent.
Rick, I know we're going to your slide here. There's a question for you. And
Yeah.
is your system able to use cameras that are already in place?
Yeah, if we can tap the IP feeds, we can use that feed as long as it's not proprietary.
Awesome.
All right. So I've been talking a lot about Detect It. We are software for AI. That's all we do. We were built for manufacturing from the ground up. We're not another AI solution that we're trying to wedge into manufacturing. This is a manufacturer's tool. That's what it's built for. So on the right, you're seeing the interfaces for Builder and Runner. Again, no code, easy to use, 10 and up. Our advantages over almost all of our competition is, again, we're camera agnostic. We're not tied to any type of camera. We're hardware agnostic, although we love Comtronics and PTZ. We don't need a stop station with a detected solution. Most solutions, you need to get the part fixtured. You have to get it set in a buck or some kind of holder, and then it's got to be perfect. If it's an inch this way, an inch that way, it's not going to work. As soon as that part enters our field of view, because we're video based, we're making detections. Um, almost all of our solutions are created and deployed in 48 hours. Like you take the video, you label the video, you train the net, you deploy it, and you're testing it 24 to 48 hours versus weeks, months, years to deploy AI. One of our biggest advantages is that our software auto labels your data with 7 different pixel trackers. For people that don't know about labeling data, you have to take images and tell the net what it's looking at. So you need to draw a box and tell the net what it is. And without Detect It, you have to do that on every single frame of data. Um, So in Detect It, if you take a 200 frame video of something without tracking, you would need to go through 200 times, draw a box, click a label. Next screen, draw a box, click a label. With our tracking system, you draw that box one time, give it a name, and send it on the races, and it auto labels everything for you. It's a huge time saver. Again, we're built on-prem, not cloud. Netrunner does not need internet to run. It's not talking to anything outside of your environment, and it's not saving any data unless you tell it to. So even though it's running in live video, all of that visual that it's getting is just dumping in the bit bucket after it sees it. It's like your own human eyes and your brain. When you see something, it's not being recorded anywhere. It's just going to your brain, and your brain's making a call on what it is. Well, that's what we're doing with Netrunner. We're not saving anything unless you configure us to save things, and you can configure us to save things. We can create birth certificates for you with date, time, location, what we detected. A lot of our customers use that, print those out, and they put them in the box with the part as a proof of, its quality. And the biggest advantage to us is that we're coder free. That there's a lot of code going on in the background, but the interface is very simple. Right back to the Girl Scouts. So
Honestly, too, with all of that being said, there's so much more. And I promised Rick I wasn't going to talk about this projected AI picture here about the at Automate, but I just want to say that, like, literally they were projecting the detections onto a part, providing the operator with instructions. I've never seen anything like it, and I guess we'll just have to save it for our next webinar in
Paul,
Q4.
to us, a projector is just another camera. It's just another way of seeing.
Mhm.
So our customers can do whatever they want with our software. They can attach any kind of camera or visual to it. This is just a clever way of taking our detection boxes that you would normally see on a monitor, and you're seeing them on a projector, which is putting them live on the part. So talk about instant feedback on what's good, what's bad, what the operator has to do without taking his eyes off the part and looking up at a monitor. Like, it's literally right there screaming at him, red box here, this is bad.
I mean, that people
Awesome.
could not believe what they were seeing at Automate this year, and you guys continue to push the envelope. So it's just, I had to say something about it, Rick. That's just the coolest thing I've seen
Thank
in
you.
a long time. So
What about you, Paul?
PTZOptics have cameras for AI, and our cameras really fit a lot of boxes for this application because they're robotic, so we can control them remotely with Detect It. They're IP connected. Okay, so this whole IP world, right, where we're sending the video over the network, is we've had that from the beginning at our company. And so though the robotics and the IP connectivity really converge into creating something that is really special, I think, in this full solution. PTZ cameras stand for pan, tilt, zoom. And yes, you can steer a PTZ camera manually, but you can also automate that process. And so Detect It creates what they call a flight path. And so essentially, if you have a part with 5 pieces that need to be checked, you can have the PTZ camera, set to move between those 5 pieces in a loop. Or as Rick was mentioning, and I haven't even seen this yet, Rick, but you can hunt for bad parts and scan parts. So this is really opening up an incredible area of innovation where, PTZOptics has the robotics. We have an API that Detect It is building on top of, and it opens up a ton of cost savings for our customers who in industrial manufacturing are used to fixed cameras, right? Where every single viewpoint needs a camera. And Detect It came to us and said, I think there's a better way here. I think we can program around your API using the robotics that you have to dramatically reduce the amount of cameras that our customers need to deploy. And that's just, I've talked to a lot of the customers. I mean, it's cost savings. There is new innovations like hunting that are coming out for this pieces. So this is cutting edge stuff. And I just wanted to share this one picture from a customer of ours. Really
This is a
happy.
great shot.
It kind of shows what's going on here. You've got your PTZ camera. And again, I just want to say one cable connected to this camera, which is just, it's different. than what you see in other places. It's powering the camera, controlling the camera, connecting to detect it. You've got detect it down here. And what you're seeing is,
But Paul, look at that level of zoom. Look how far away you are, and you're looking on that one little piece up there.
it's all about 20 feet away from the piece, which is necessary in a lot of applications. You can't have a fixed camera in this area. With this piece right here, the operators need to be able to access it. Putting in fixed cameras with cables and everything that close to the piece would just be intrusive to their workflow. So getting 20, 30 feet away, whether you're above or to the angle, really helps us keep the technology out of the way. And as Rick mentioned, I mean, look at how close the zoom is down here, where you can really see the part and make detailed detections. In this part right here, there are 400 unique cables that make up a manufactured part that is about $250,000, specifically designed for pharmaceuticals. And there's a lot of checks that a person has to make. And there's a 50-page manual. And mistakes get made often. I'll just say often, because I have a lot of respect for what they do, and it's a difficult job. When we came in and said, listen, there's a lot of parts here, and there's a lot of detail, and we're going to have to zoom into each piece. And yes, that process with that many pieces takes about 15 minutes, but it used to take 8 hours. So taking something that takes 8 hours down to 15 minutes is a huge, huge time saver. And yes, there's still a manual check with the QC team. You know, there's still a manual QC person signing off, but their job is that much easier. They feel that much more confident about signing off when Detect It is telling them there's a 99.9% accuracy that it's correct. So just wanted to show that picture.
Awesome.
I mean, this is what we're seeing out there. It's just really awesome. So that brings us to questions, and we've already gotten quite a few. So thank you for submitting your questions, everybody. We love to hear your questions and answering them. So if you've got any, let us know. We are committed to doing this quarterly. So it seems to be that's probably a good pace for us because Detect It's got new stuff coming out. Comtronics
Yeah,
has
and we
new
decided
things.
this first one was going to be high level, but the next one's going to get a little more into the weeds.
Yeah, we're gonna like kind of slowly get more and more advanced, and then maybe we'll just have these older ones available on YouTube if someone needs to catch up. Because in 3 or 4 quarters, with the rate that Detect It's moving, we're gonna be pretty deep. But we got a question for you, Rick.
Yeah.
So with PTZOptics, all I need to do is connect it using a PoE network switch, and I get a direct feed in Detect It. If yes, question for Detect It. Is it just for PTZOptics cameras, or can he use other cameras too?
You can use other cameras too, as long as they're not proprietary. You can use webcams, you can use boroscopes, you can use security cams. You can use industrial vision cameras. Anything you can connect and get a feed from to a monitor, you can use for Detect It.
Okay, and Kunal's asking if he can get a recording of this. And yes, we have recorded this. So we will be sharing a recording of this. In fact, Zoom events, everyone who's registered for this event, when you go back to the Zoom event link that you registered for, it will automatically show the recording. But we're also going to be staying in touch and sharing this video out so that everybody has access.
Perfect.
Thank you so much
Awesome.
for joining Jimmy and Rick and everybody else.
Yeah, thanks for
a lot of
hosting us, Paul.
excitement here. You're welcome.
Yeah, thanks, Paul.
And everybody, thanks for joining.
Yeah, thanks, everybody.
Thank you so much, everyone. We'll be sending y'all a invite to next quarter. So if right now we're in July, we're probably looking at August, September. We're probably looking at October for our next webinar. So keep a lookout for that, and we'll be in touch.
All right. See ya.
Thanks, everybody.
Bye, everybody.
Bye-bye.